Good morning friends. Today we are going to discuss about the dynamic programming. Okay, in the previous classes we discussed about the greedy methods as well as the divide and conquer techniques here. Okay, dynamic programming is the most powerful design technique for solving the optimization problems here, right? But in divide and conquer algorithm, what we are going to do, that one we are going to take the one problem here into disjoint. We are going to divide that one into disjoint problems to solve the sub problems recursively, and then we are going to combine the solution to solve the original problems. Okay, whereas in the dynamic programming it is mainly used when sub problems are not independent each other. For example, when they share the same sub problems. Okay, in this case divide and conquer may do more work than the necessary because it solves the same sub problem into multiple times here. Okay, but dynamic programming is the bottom up approach. Here we solve all the possible small problems and then combine to obtain the solutions for the bigger problems here. Okay, similarly in a dynamic programming is a algorithm design in which an optimization problem is solved by a combination of achieving sub problem solution and their appearance to the principle of optimality. Okay, now we are having the different characteristics for the dynamic programming. One will be that optimal substructure here. If an optimal solution contains the optimal solution, then the problem exhibits the optimal substructure here. Okay, similarly overlapping sub problems. When a recursive algorithm would visit the same sub problems repeatedly, when a problem has overlapping sub problems here. Okay, if the problem has the optimal substructure, then we are going to call the recursively define the optimal solution here. If the problem has overlapping sub problem, then we can improve and on a recursive implementation by computing each sub problem only once here. Okay, at the end, if the space of the sub problems is enough, okay, then dynamic program can be much more efficient than the recursion here. Okay, if the problem does not have optimal substructure, there is no basis for defining the recursive algorithm to find the optimal solutions here. Okay, if the problem does not have overlapping sub problems, then we don't have anything to gain by using dynamic programming. Okay, next we are going to discuss about the components of dynamic programming. Okay, we are having different components here like states, decision, and the optimal policy here. Okay, what the states is telling that the problem can be divided into several sub problems which are called as a states here. Okay, a state is a small portion of a given problem. For example, in a shortest path problem, they were defined by the structure of the graph here. Is going to define as each stage has several states associated with it. The states for a shortest path problem was the node reached here. Okay, decision in each stage there can be multiple choices out of which one we are going to take the decision here. Okay, optimal policy, it is a rule which determines the decision at each stage here. A policy is called as optimal policy. If it is globally optimal, then it is called as a Bellman principle of optimality. We are going to study on the Bellman-Ford algorithm also. Okay, next there exists a recursive relationship that identify the optimal decision for stage j, given that stage j plus 1 has also going to be solved here. The final stage must be solved by itself. Okay, now we are going to compare the divide and conquer technique and the dynamic programming. Okay, as we know that divide and conquer technique, first we are going to divide the problem here, then we are going to conquer that one, okay, recursively, then we are going to combine here. But in a dynamic programming, first we characterize the structure of optimal solution here, then we are recursively define the values for optimal solution, then compute the values for optimal solution in a bottom up minimum technique. Okay, these all characteristics we are going to study while solving the algorithm here. Okay, now second one, the dynamic divide and conquer is a recursive, but it is not a recursive here. Okay, in the dynamic it does more work on a sub problems and hence has the more time consumption here. It's in a dynamic it solves sub problems only once and then stores in a table here. Okay, the divide and conquer technique is a top down approach, whereas dynamic programming is the bottom up approach here. Okay, in this dynamic divide and conquer technique, sub problems are independent of each other, whereas in the dynamic programming, in these problems are in the interdependent, that one. Okay, just to note that interdependent. For example, merge sort and binary search sort example for the divide and conquer, whereas in dynamic programming, matrix multiplication will be example for the dynamic programming. And finally we are going to discuss about application of dynamic programming. Okay, 0 1 Okay, 0/1 will example for 0 or 1 knapsack problem is there. Already we studied knapsack problem in a greedy method is different. 0 1 knapsack problem is the different here. Mathematical optimization problem, all pair shortest path problem, reliability design problems. Okay, flight control and the robotic control is in flight control and robotic control dynamic programming is going to be used. Okay, time sharing, it schedules the job to maximize the CPU usages. Okay, these all are the application for dynamic programming. Okay, in the next class we are going to discuss about the different examples for the dynamic programming. Okay, like Bellman-Ford algorithm is there. Okay, Warshall's and Clyde algorithm is there. Okay, we are having the multiple matrix multiplication algorithm. All these algorithms are going to discuss in the next class. Okay, thank you.